Conditional probability. The probability of A, given that B has already occurred, is equal to the probability of A and B divided by the probability of B. Therefore, if you rearrange that equation, the probability of A and B is equal to the probability of B times the probability of A, given that B has already occurred. Remember that the probability of A and B is equal to the probability of B and A. Therefore, the probability of B and A equals the probability of A times the probability of B, given that A has already occurred. Therefore, combining the two equations for the intersection, the probability of B times the probability of A, given that B has already occurred, is equal to the probability of A times the probability of B, given that A has already occurred. Example 1. Andrea is a very good student. The probability that she studies and passes her mathematics test is 17 out of 20. If the probability that Andrea studies is 15 out of 16, find the probability that Andrea passes her mathematics test given that she has studied. Let S equals studies. Let P equals passes. Therefore, the probability of she passes and studies is equal to 17 out of 20, and the probability that she studies is 15 out of 16. We want to find the probability that she passes given she has studied, which is equal to the probability that she passes and studies divided by the probability that she studies, which equals 17 out of 20 divided by 15 out of 16, which equals 17 out of 20 times 16 out of 15, which when you work it out comes to 68 out of 75. Question 2. The probability that Janice smokes is 3 out of 10. The probability that she smokes and develops lung cancer is 4 out of 15. Find the probability that Janice develops lung cancer given that she smokes. Let S equal smokes. Let C equal lung cancer. Therefore, the probability she smokes is 3 out of 10, and the probability she smokes and develops cancer is 4 out of 15. We want to find the probability she develops lung cancer given that she smokes. Remember, the probability of S and C is equal to the probability of C and S. Therefore, the probability of C given S is equal to the probability of C and S divided by the probability of S. Therefore, 4 divided by 15 is equal to 3 out of 10, which is equal to 4 out of 15 times 10 out of 3, which equals 8 out of 9. Example 3. In a group of 100 students, 40 were randomly put in a Monday art class. Independent of that event, 30 students were randomly put in a Tuesday botany class. If a student is chosen at random and is in the art class, what is the probability that he or she is also in the botany class? Let A equal art, let B equal botany. We want to find the probability that the student is in botany given that she is in art, which equals the probability of B and A divided by the probability of A. Because the events are independent, the probability of B intersection A is equal to the probability of A times the probability of B, which equals 0.4 times 0.3, which equals 0.12. Therefore, the probability of B given A is equal to the probability of B intersection A divided by the probability of A, which equals 0.12 divided by 0.4, which equals 0.3.